Hello, everyone. My name is Marcin Stożek. I go by Perk. I work for Sumo Logic, and I'd like to present you how to train your Bash. The story, maybe the horror story, maybe not, about how to write your script so that then they don't bite that much, because they will. But maybe we can do something so that they don't bite us all the time. This is, I like to call it like Alcoholics Anonymous meeting, or maybe, Bashers Anonymous meeting, because nowadays, even though we write in, so many different languages like Java, Scala, Python, everyone, you name it, everyone has to write some Bash at some point, because that's the world we live in. Actually, we have Docker containers, we have DevOps culture, so everyone needs to do a little bit of automation, and there is that's actually where this Bash presentation is coming from, because it's very good to know how to write the proper Bash scripts, so that we don't have problems with them later on. Let me start this story with this example from Valve. Actually, this is about the client. This is a code from the Steamroot client, and it's very good that we have this comment, actually, because there is 4 lines, and this is very cryptic. I mean, what does it mean? Like, you cd to a directory, but it's not a directory. It's like $0% and then you echo the current directory. It's like, without this comment, that would be very, very bad. But it should work, right? Because it's Bash and someone wrote it, so it probably is okay. But there is a problem with this line. I mean, maybe not with this line, but the problem is somewhere later on that there was this issue. It's at the bottom issue of the Valve GitHub repository, and there is no source code, but you can file a bug, and the bug said, "Dear Valve, everything is okay, except that the Steamroot is later on called like this." And if you know Bash already, you should know that this is not a very very good example of how to remove something from your application directory. Because the problem is, if the Steamroot is empty, then we try to delete everything from the root directory, and it's good that we don't have the no preserve root in here. And that happens because of the Bash default settings. That happens because Steamroot can be empty, and it was with this issue because Valve had a bug that when you reinstalled the directory, the variable was empty. And that's what happened. The guy that filed the issue told, "Dear Valve, I just lost 3 terabytes of data of my backups, and I wonder if we could fix that." Luckily the guy had backups of the backups, so he was covered. But I would rather be like this, like, "Oh, come on, why did this happen?" And it happens because we write our Bash scripts, I would say, carelessly, because it's Bash. It's very simple, right? You just write and run, and you're done. Let me start with this. What is Bash actually? Because this is pretty important, I would say. So we should say that Bash could be shell, right? I mean, it's shell. You can open Bash and you have this command processor, right? But Bash is also a command language, and the command language is a subtype for the scripting language. That means that it was written to run jobs, to take output of one command and pass it to the other command, and the other command takes the output of the first command, do something with it, and then passes it to another one. and runs some other jobs. So this is a DSL for job control. It's a Turing complete language, so you could write everything in that, of course. And the problem with Bash comes from the thing that people do that actually. So they try to do, they try to write programs in Bash that are too complicated, and Bash is not a very good fit for that. This is DSL for just for job controls. I mean, don't get me wrong. I personally wrote, maintained. I didn't write it. I maintained a script, Bash script that was 2,000 lines long. It was 3,000 at the beginning, and after applying some of the rules that I will show you later on, the script was bearable. I'd say it was like people came to me and said, "Okay, I can write this Bash script, so I can read it, and that's a good thing, right?" But we shouldn't do that. We should use it for what was it written for, originally. But that's that's the world we live in. Sometimes we can't do anything about that. So it's good to know how to make our life easier. We can ask the command what is about Bash itself. So what is Bash? I mean, we can ask what is, we'll say what is what, because it expects some arguments, so we can ask about Bash, and what is will say that Bash is a GNU born-again shell. And this presentation is about Bash and not the other POSIX compliance shell. And the reason for that is that we quite often write scripts that will be run in the Bash and not in the POSIX compliant shells like Bourne shell or Thompson shell. Or maybe if we have Alpine Linux, then maybe we'll have those POSIX compliant shells, but then we can additionally install Bash as well, and we'll have Bash. And I chose that because Bash gives us some features that are not in the other shells that are I would say crucial. At least one of them I will show you later. And Bash was written in the 1989, and it was re-implementation of the other shells of this Thompson shell and Bohr shell, because GNU project had many scripts, and the guys from GNU thought that maybe it's time to have their own scripting engine, so that they don't rely on the proprietary on the other proprietary products. The what is command is very might be something funny. I don't know. I think it's trolling sometimes, because you can ask about the other languages, and it will say sometimes it will say this. It's it's not me. You can ask your Bash. You can ask your what is, and it will say all the things. When we start writing our Bash scripts, and that's the problem, as I said before, those are pretty small, because I just want to write something in my Bash that is like 5 lines long, and then after some time we have a problem with that. So at the beginning the situation is very clear. The Bash is concise. We don't have much problems with it. But after some time, and I've seen it on production, we start having problems. And but I'm not sure. Do our Bash scripts look like this? Are they magnificent? Do we fear them? I mean, we do fear them, right? But I don't think that that's a very accurate picture. The more accurate is that one. That's how the usual Bash script look like, I would say. And I saw quite a lot of them. Okay, let's try to tame the beast. So first very important thing: Bash has not a type. This is a myth that variable has a type in Bash. In Bash, everything is character string. So we can say that Bash is strongly typed, actually. if we have string that contains only digits, we can do some arithmetic operations on it, and also there are arrays. But for the purpose of this of this presentation and for our own sake, I'd say let's think about bash variables that those are only strings, and that will help us a lot. That will really help us a lot. We have this $sign variables those are very cryptic. That's the problem, right, with bash, because it's very cryptic. It has this $1, $2, $hash, $@. So what are those? So the first four, they can go. I'm not sure if more than 10 actually, because I've never used more. But those are positional parameters. So these are the command arguments that can come to your script or to your function. It's like literally the first, the second, the third, the fourth, and so on argument that came to your script. We can get the number of parameters with the $hash, and the next two are the positional parameters in one variable, but they differ. So the first one is all the variables, but each of one of them is in the double quotes, and the other one is those parameters, but they are split by the IFS. IFS is internal field separator, is used for word splitting. And that means that by default the IFS has space, tab, and new line, if I remember correctly. And so more, probably we don't want to use the $asterisk, the positional parameters with $asterisk, because the default IFS, I would say, it's not the could have better defaults. Actually, the space in there could not be there, and that would help us in some situations. Okay, so we have also the $0. So the $0, so the first parameter is the name of the script. We can get the pid of the current shell of the current script with the $, pid of the last command that was run, and the last command exit status with the $, and the question mark. So there are a couple of those, and if you write bash scripts, you just need to learn them. You just need to look in the documentation and see. But those should suffice for the most for the most scripts, I'd say. Okay, rule. Let's go to the rules. We have a couple of rules. First rule says always use quotes. If you want to echo something or you want to assign something, always use quotes. And the reason for that is that if we don't use quotes, we will let bash to do some processing on the string that we pass on. So the asterisk is a special character in bash, and this special character, as we can see at the bottom, is just files in the current directory. So we can see in the example. Let's go from the top. We have this variable 1, 2, and asterisk. So this is a proper assignment. I will also show you later why we should use the double quotes in here as well. And then we do two things. First one is echo in the double quotes. We echo this variable, and we see 1, 2, and the asterisk. So something that I probably wanted to do. And the other one is echo without the double quotes, and I can see 1, 2, and then bit, put, cdrom, dev, etc. home, etc. And the reason for that is that asterisk, the bash do something that is called file globbing and file split, and it just took this asterisk, processed it, and put the input in here. So make sure that you use quotes so that resulting string is something that you wanted it to be. Okay, now how to assign something to the variable. And on the left, we have wrong assignments. On the right, we have the proper ones. Why is that? Because there is just no space in bash, and if you don't put if you do put space, you just get something totally different. So we have these examples. Let's see at them from the top. First, we have full space equals space bar, and we say we have that full is command not found. That's because bash tried to run the full command, and it was just not there. There's this very helpful feature in bash that helps us set the environment variable just for the command we run, and that's what the two examples below are about. So at first, we just check what is in our env, and then we pipe and grep for the bar. And we see that we have no command, we have no environment variable with the bar string. And then let's see, we first says that the full equals bar, and that is an environment variable, and we pass this environment variable only to the env command. So the env command is run with this environment variable. Then we pipe and grep the bar string, and we see that it's there. And this is very interesting because this full is of course trivial, but there is one that is worth noting, and it's called LD preload. And LD preload says what libraries should I preload before running the command. So we can change, for example, libraries for, I don't know, SSH or CP before we even run the command. So if we compile another binaries, another libraries, we can just, without recompiling CP and then do some other hackery, we can just, set the LD preload to our libraries, and we'll have our libraries loaded. And assignment quotes. Why do we need to have the assignment quotes? On the left, of course, this is wrong. On the right is proper. Why this is wrong? Because on the left, because as you can see in the examples, if we do ownership equals has a cat, then what do? We actually try to run command has with the environment variable ownership equals and then to this has command we pass two arguments, a cat, and that of course cannot work unless you have the has command. I don't actually in my bash environment. So if you put that in the double quotes, then we can see that the echo command is working properly. We could not have the double quotes around the ownership, the echo ownership. But as I said previously, if we had a special character, then we might have the problem with bash interpreting this the string, the characters in the string. Another good idea is to use immutable globals. Let's make our variables invariable. Let's make them read-only. It's possible in bash, and it's very, very helpful. I mean, in bash, sometimes we need to use the global variables. We can try not to, but it's harder than not, of course. But we should keep them to minimum, of course. Let's use the uppercase format so that we have this consistency across other scripts, because there's the unwritten rule about those. And please make them read-only. We do them read-only. We cannot change them. They are global variables. Let's not change them. We can do in bash this, like we can first set the variable to something and then make it read-only afterwards. So we can lock the variable at some point. That's sometimes a very good idea as well. We can name the parameters. This is this is something that's helpful because the parameters that come to function or to your script are, as I said before, $1, $2, $3, and so on. That's not helpful. It doesn't say what are those parameters are about, right? And here we have the examples with the functions, but we can use exactly the same example. I mean the parameters, exactly the same thing with script itself. So let's see at the do, because the don't is pretty obvious. We have the function which lists files, but we have no idea what is this argument about, right? We need to read the function itself, and it's not very obvious. And that's also the problem with Bash, which is we need to read what is inside, and this is very cryptic. So we lose time into rereading code if we don't have the proper naming, for example. But that can be fixed, and one of the fixes is the naming the parameters. So in the second example, we can see that we have this function list files, but then I use the local keyword means will be explained later on, but it's just local. I have the variable which I can call type. So I know that this first argument, because the assignment says, let's use the first argument, or it was empty, then use just the temp. So I know that that was a type, and I need to pass the type to my Bash function. So then when I have this call find.iname and type, I know that it was all about the type, right? So that's easier. Okay, how to know your arguments also. This is something that can be nasty. I've seen many times, and that was that's just widely used, I'd say. On the left, we have this example: how to iterate through your arguments. And the way to do that is many times to just get all the arguments, which are $at, and then you do something with the first argument, and then you shift. And shift means get the first element and just throw it away. And we do it in a loop. We do it unless unless we have nothing in the $at variable. That's fine until we want to use the $at somewhere else, because at that point, when we do all those shifts, the variable is empty. We cannot do that twice, and that's the problem, right? Because maybe we would like to use the arguments like multiple times, right? So how to do it? And on the right, we have the answer. So first, we can pass all those arguments into the array. We declare the array. This declare -a, and -r is read-only. So we make this array read-only. We call it args, and then we have all our arguments in the array. So we can use it, like array. We can iterate through array, and then we can use it. As you can see, that's a call for the main function, and we pass all those arguments, and we can use it. How many times we want. We just take it and use it, and no problem, and no problems. And how to do it, and why actually to do it. So here we have 3 examples. First example takes the $at arguments and put them in a variable. Then we iterate through this variable, and we just echo the result. So I can see this is a function. This is a function called fun, and then I call this function, and I call this function with 2 arguments. First argument is 1, and the second argument is foo space 3, right? So what I'd like to see is 1, and another line 2 and 3. But if I do that like in the first example, I just pass it to the variable, and then I iterate through this variable without double quotes, I just get 1 through 3, in the lines, because every argument is treated without double quotes as something that needs to be run against the IFS. So I just got the split because IFS by default use space. In the second example, it's very similar, but the args is in double quotes. And when it's in double quotes, then I say to Bash, this f will be just whatever is in the args. So it's treated like a string and no processing is applied. But then when I call this function, I just go 1 through 3 in one line, because that was just a script, and I wanted it to be something different. So in the third example, I have something that's working the way I wanted it to work. So I declare the array. I have this array with the arguments. I iterate through this array, and I echo. And as you can see, I have this 1 and then 2, 3. So something that I wanted to have, and I'm good. This can save sometimes time, because I think this is a very neat trick to have your arguments properly processed in your bash script. Use explicit paths. That's actually something that it's not necessary, but sometimes can help. If we use not explicit paths, I mean just file in current directory, in all the files in current directory with asterisk, and I do something with this file. So the comment something can behave differently. Can behave differently if it gets the file name, and it can behave differently if it gets the full path with the file name. That's the case for tar, for example. And many times it's just easier, and the result is something is more aligned with something that we thought the command would do. Also, if we need to do some recursion, we should use really find command and not do that in bash, because in bash, in fact, if you have too many, for example, if you have a directory which has too many files in it, and we try to delete all of them with this approach on the left, this won't work, because bash will get too big list of the files. So we need to use find to delete all those files. Subshells. Now let's go to subshells. The first subshell is the dollar subshell. Dollar and the parentheses. We should use those dollar parentheses instead of the backticks. That's because the backticks are actually quite legacy, and they are harder to read. If you if you can spot the difference between backtick and the single quote, then that means that you are probably a seasoned programmer, because when I talk to people who are just new to the programming field, they many times just don't know that there is this backtick at all on the keyboard, and we say, oh, that was a backtick and not a single quote. Where is it on the keyboard? And you look at it and, okay, this is somewhere there on the left. Yeah, left up. Oh yeah, it is there. So that's not very obvious, and if we use that in the bash script, it's not obvious as well. I think it's better to use the dollar parentheses example, because it's more readable and it can be nested easily. You just nest easy. You just use the dollar parentheses and another parentheses, and you can nest. And if you do this, if you would like to do that with backticks, you would need to escape them, and that's not a very good idea, because this renders our scripts actually unreadable, right? And there is another type of subshell. The first one with the dollar, now without the dollar. And the difference between the two is that the dollar one returns a value, and the other one don't return the value. But they are both quite helpful. But by that I mean sometimes we just want to run some command. We would like to run a command and get its output and put that in the variable. So that was the first, the previous example. Or we would like to run the command in some subshell, but we don't want to change anything actually with this subshell. We with current shell, I mean, and we want to change only inside the subshell. So that's where we use this this type of subshell. As you can see on the left, if I'd like to, for example, I have something in my variable, and then I would like to replace this variable, do something, and then I need to bring back the backup. I don't need to do this. On the right, we have how to do it. I have my IFS variable. Then I use the subshell, and I change in the subshell IFS to just new lines, and then I echo this IFS. So that will happen inside the subshell. Inside the subshell, the IFS is changed, and then outside the subshell, I can echo IFS again, and I am back to my to my previous variable. Nothing changed. That's very very helpful. For example, sometimes you would like to add some debugging or something, and you don't need to do some hackery around it, some boilerplate. You just use the subshell for that. We should split pipelines. Actually, we should split pipelines with with this character, and that's because pipelines don't look like this. We don't have pipelines that just run the commands, first command, second, third, because that's readable. Okay, that's fine. But what we do in pipelines, we run the command, and we add some arguments to this command, like list all the files, grab all the files, then do something with the AWK with them, and then, I don't know, get the second column from that, and so on and so forth. And if we have multiple of them, it's not only that the line is very long, but it's like when we do, for example, a change, we don't see this change in Git easily, in the Git diff easily, because the change was somewhere there in this very long line, and we know that I don't know, like we added something, but it's not obvious when we just spot this. So let's try to split them as we have on the left. And in this case, when we just add a line, we will see it instantly, and Git diff will show us instantly what the change was really about. We have also another example on right. This is how we could conditionally run some commands. This will work. So I would like to run the first command and the second command and the third command, and if something won't work, then I would like to run the fourth command. Like, for example, first command, then second fails, so I run the fourth one. And this is fine, but we need to be careful with that, because in Bash, Bash takes the return values from the commands and not the output. And we do most of the things with the outputs inside Bash, but sometimes we need to take care of the exit values as well, and that can get confusing actually. So let's be careful when we do this kind of binary operations, because they are not really binary. It's not real, true and false actually. We can use the conditional expressions from the Pure Bash Bible. Pure Bash Bible is there is a link at the bottom, and this is very helpful if we have the environment when we expect not to have some kind of commands, or just outdated outdated applications, outdated binaries. For example, I don't know, if you use Mac, then you probably have unless you install your own bash and all the other commands you use. By default, you have the very old versions of, for example, bash, and then if you try to use some external commands, you would for sure you will have problems. Like, I don't know, like CP has different arguments. So sometimes you just can use something inside bash and with the bash commands only. Like here I just put the trivial examples, like see if the length of string is 0 or non-zero, or if they are equal, and so on and so forth, if the file is executable and so on. But if you go and see in the link, there are like examples sometimes are mind-blowing. What can you do in bash? That, of course, does not look very friendly. I would say that's the problem with bash. But if you put that in a wrapper, in a function, that's not that bad. Then it can be okay. Okay, and that's the example I said at the beginning. I told you about at the beginning. And that's the reason I'd rather use bash than the other shells. It's about those parentheses. So this is about if command, actually. If something, then something. And this is tricky. If you use this single parenthesis, we have different command than when we use the double parentheses, and the double parentheses are built in the bash itself. The single one sometimes is built in as well for the into bash, but sometimes it's not, and you probably have like two, so you never know which one you call. But anyway, let's see at examples. First example, the file equals bars. That's like totally wrong, because it's not the bar that should be quoted, it's the file that should be quoted. But the second one is evil. I mean, it just tests if one is greater than 2, right? And that's what I thought, actually, and that is wrong, because it's not what it's about. The problem with this example is that it's not also very obvious as what it is, actually. If you ask people, they can get very confused. So I did this presentation a couple of times, and I thought a couple of times, like, yeah, this time I really know it. So hopefully now I know the proper answer, but that got me after a couple of iterations. So this is not 1 is greater than 2, because that should be false. And if you run this on your laptop, on your machine, this will be probably true, actually. And why is that? Because this tests if 1 is empty. I mean, 1 is a string. It's not 1 as a number. It's a string, and if tests if it's empty, and because it's 1, it's not empty, right? So this will pass. But there is this another one, greater than 2, and it's not actually greater than true. It's moving your output from the command that was not there to the file which is called 2. So if you are on the if you are on the read-only directory, it will fail. So this is totally twisted. This is totally twisted. And as you can see at the bottom, if you use this double parentheses, you got the same result, and that is very important, because it just works the way it's. Maybe let's not say the way it should, but it works the way you expect it to run. So yeah, that's a very important one. And let's go to functions. We have functions, and we should use them. It will, make our scripts look prettier. They will, clean code and so on applies in here. Especially in bash scripts, where everything is cryptic. someone tried really hard to write this, so then someone else should really try hard to read it, right? I don't think that's the case. We can use functions and we will be good, right? So what this example do? We just need to read it, right? It goes to some path and then it finds some files, the temp files, and deletes them, right? But why do it? We could do it the other way. We could just write the function which is called delete temp files. And we don't even need to go into the function. We don't need to read what's inside because we know what it does, right? And that's a very, very good approach. And functions have a couple of advantages that are quite important. Like first of all, the variables can be local inside functions, and that's very important because I don't know if you know, but every variable in Bash is by default global unless you set it to local, and local can be set only inside function. So we have leakage. The variables can leak. You just set something in your function and then you have it somewhere else. Like a couple, maybe not hundreds, but if you're lucky, lines later, like you have the variable and it's it's set and you don't know out of where actually. So if you should use local, and you can use local inside function, and then you have proper namespacing for the variables. And also the code is easier to debug. As I said, you just write the code, you name the code, you name the function, so you know what's the purpose of the function. You can set some debug. You can set debug inside the functions only. I will show you later on how to do that. The code is self-documenting, and also it's easier to understand the code flow. Because when I write Bash script, I try to use as many functions as possible. So then I just read that. Okay, this Bash script does this and this and this and this, and you're done. I don't even need to read all of those functions because I just read the names and I know if there is a problem or not, and this it's separated. So if there is a problem, for me it's easier to find it. And why we should use this local? As I said before, we have this global by default. So here's the example. I have two variables. One is mech and other is blach, and I have this function. And as you can see, the blach variable is global, and the mech is nice local. So if I run this fun function, and then I echo mech, it's empty. And when I echo blach, it's global and it's out there. It leaked. So hopefully we are not screwed, but probably we are. And if we have functions, we can also use the main function, right? So that's the entry point to our script. I don't need to look anymore, through all of those lines in my script to find what it does. I just go to main, and then I have the normal code flow. I have the main function, and main function calls this and calls that, and so on. Of course, I need to be careful, because in Bash I can write whatever outside the functions, and then I would have some code running, and nothing is stopping me from that. But I try to use main function as much as possible. If I do that, then most of my variables can be local, because everything is functions, right? And that's very helpful. And if we have like very, very short script, I don't know if we should bother, because as in here in the example, there's a similar example. We could write it without the main function, but if we go under some threshold, I think it's very good idea to use the main function. And if we have these functions, then what can we do with them? Let me show you. So we have functional bash, right? And in here, what you can see, we have the higher order functions, like normal functional programming. So we have two functions here. One is called stało się, and another one is stało. And those functions just echo the string. And then we have the third function, which is called co się. And this function, what it does, it takes the argument, it runs this argument in subshell, put the result into the environment variable, and I mean not environment, into the variable which is called co, and in English co, and then it just echo. So you can say that the co się function is just a decorator. And as you can see, I just run those two functions, co się, stało się, and then the co się stało, and I have those strings decorated, right? And actually, this works. This is like this is proper functional programming in Bash. You can go through those links at the bottom, and you can do very interesting things with that. I've used that in a couple of my scripts, and sometimes it helps with my code flow. So if we have functional programming in Bash, then we have Bash monad as well, right? Because why not? Okay, so pipe is not a pipe anymore. It's equivalent for this operator. This is a part of monad, and unfortunately, I don't understand any of this. But the guys on the internet, someone on the internet probably is right. They wrote this, so and they wrote it out in the wild. So let's go and check. Right? I asked a couple of my friends who are functional programming gurus, and they agree. They agree. So that's totally cool. But you know what? Let's not go rewrite your Scala in Bash right now. The code won't be more readable. It will, but maybe the compilation time will be faster, right? Because there is no compilation time. But execution time matters as well. But yeah. If you have your code in Scala, it's not a good idea to rewrite it in Bash. So we are going slowly to the end. There is only a couple of more rules. First of all, the unofficial strict mode. Unofficial strict mode says how to write your Bash script so that they don't bite you that much. And the first one, exit on all non-zero exit statuses. That's very important because if any command exit with the non-zero, I mean it fails, your Bash script will fail. Another one says that if you have any undefined variables, you'll exit with the problem. Same for pipefile. I mean, use the same for pipefile because by default you don't. And as I said before about the IFS, you split words on the new lines and the tabs only. You don't split because by default there is a space as well. And the space means that you sometimes get the results you were not prepared for. You can clean after yourself, so you can have this trap function. And if you call on exit, you just run the function. That's very helpful because sometimes you just set up the AWS machines. Then you have this cleanup function. So when you break the if you have any problem with your script and something goes bad, then at the end this cleanup function will be always called. So for example, you can just bring down all of your machines even though you had a problem with your script, and you just don't leave any leftovers. And this is very useful with -e command, in case something goes wrong. You can use the debug mode. So you just set -x, and you have all the things that Bash do wrote on the screen. So Bash did this, Bash did that. You can add the -x, as you can see in here, all of those examples. So you can set it at the top of your script. You can add it to the shebang line. You can add it, around some buggy function. You can even run it with your script outside the script. So you can say Bash -x, your script, and then you have all of the debug line. And how does it look? It's very, very cool. As you can see, I have this very, very simple main function, and I can see all of those steps in here written. So what it does, what it did, it called the main function with the 1 and 2, 3 arguments. Then it was this for loop equal 1, 1. Then I had another for loop equal to 3, to 3. Everything is there. If you have a problem with the bash script and you don't know what it's doing, use the -x, because it will tell you instantly what's going on. You don't need to have, you know, the it's called the logging driven development, when you add some log around some code so that you know what is going on. You don't need that. You don't need to do that with bash. You can log your output easily with this info warning error fatal. This is a very good idea, actually, because this way you will have the structured logs from bash scripts, and also it will go both to your screen and to the file with the help of the T command. And you can add the timestamp in here, so that you know your logs look pretty. And this is important thing as well. We should all use shell check. Shell check is a script that is a tool to static analysis. It gives us warnings and suggestions. It says if our script is okay and if it's not okay. It suggests how to improve our style. It checks if we use command incorrectly, and that's very, very good. And as you can see here, I have like very, very easy script. I call it scriptic. And when I run it again, the shell check, I get tons of warning messages, like what can go wrong, right? Like I have undefined variable. I should use should use backticks for subshells. I should use double quote for to prevent globbing and word splitting, and so on and so forth. This is very important. It should be, you know, tied into our CI pipelines. You know, whenever I have a bash script, I should have shell check trying to see if the script is safe or if it's not. And you know, if Steam would use the shell check, they would not have this problem, because there's this rule, and you know, shell check would give a warning. And actually, that's not entirely true, because this rule has been added after the Steam problem. But you know, anyway, now it's there, so the word would be better. The example here why shell check says that we should use this Steam root and this question mark. It's because in this way the bash would just end the execution, because the Steam root variable is empty. There is a style guide for the shells. It's written by Google. It's battle tested. It's good to have conventions. So it's good to use that. It promotes good practices. You know, many things in these presentations came from the style guide. So I think it's very good to use that. And I hope you will do. And there are unit tests. You know, there are unit tests with bash. You can do some unit testing if you have very complicated bash scripts. Let's make our world better, right? And use the library. This one, and we are almost done. This one is sometimes we have problems. We just wrote, you know, like 5, or we have even 3 lines in our bash script, and it doesn't work, and we don't know why. Why on earth it doesn't work, right? We have this but interpreter no such file directory. I just, you know, whenever I see that, I laugh, because that's a problem with the line endings, and bash will just say this is a bad interpreter, no such file directory, and yeah. That means that we had 2 machines, one for example in Windows, one in Linux, and we have mixed line endings, and the bash script will not work. So we just use the tool like DOS to Unix or something. We just need to convert all the line endings, and we are good. And okay, because that was actually most of it. And if you like this, there is one more very, very important rule. And here it goes. If your bash script is more than 100 lines long, please use the Python instead. Python was, or any other scripting language, or any other language that was, its purpose is to write programs and not do just jobs processing, right? We should use tools for the proper problems, and we should not use Bash for everything. Here are the links. If you want to see some more Bash, just go through them. They are worth reading. I know that writing in Bash is very easy, but writing properly is not. And I urge you to learn some Bash. And that's it, actually. Thank you for listening. And let's hear back from the studio.